This is the lecture number 9 for the chapter integration, and we were discussing the last lecture, the 7.4 exercise, and this based on the special integral, and in that we were integrating by making the perfect square of the quadratic polynomial or linear upon quadratic type questions. Same question we will discuss again in question number 22 of 7.4 exercise. This is linear upon quadratic type question. In the numerator we have linear polynomial, in the denominator we have quadratic polynomial. What we have done, or we have done in the earlier question, we try to find make the in the numerator the derivative of the denominator. So what is the derivative of the denominator? It's 2x minus 2. So you have to make 2x minus 2 in the numerator by arranging it. So I multiply numerator and denominator by 2. So I have got this 2x plus 6. Now I need minus 2. So I have minus 2 added and subtracted. So minus 2 plus 2 plus 2 plus 6, it is 8. So as usual, break into two integration containing one integral, the derivative of the denominator, that is 2x minus 2 upon this and 8 upon this, taking care of this half sign. Half into 8 will be equal to 4. Now let it equal to t, because the derivative of this is 2x minus 2. When you let this is equal to t, so this will be cancelled out. It will become dt upon t, and here you have to integrate by making a perfect square as usual. So how you make it a perfect square? Adding and subtracting the half of the square of the coefficient of x, which is 1. So half of 2 is 1. Adding and subtracting the square of 1, that is 1 square minus 1 square. So it comes out to be x minus 1 ka whole square, and this is minus 6, which is root 6 whole square. So this is a special integral of 1 upon x square minus a square, and this is 1 upon t, which is log t, log of mod t, replace the value of t, which is x square minus 2x plus 5, and this is a special integral of 1 upon x square plus minus a square, which is 1 upon 2 into a log x minus a upon x plus a. This is the question we have already done, and this we can say that we have revised that again. Similarly, is question number 23, linear upon quadratic type question, in which you have to integrate it. You have to make the derivative of the quadratic polynomial in the numerator. What is the derivative of the quadratic polynomial? It is 2x plus 4. So I am trying to make it here 2x plus 4, because the coefficient of x is not 1 in the numerator. So you make it 1 by taking 5 common in it. So take 5 common in the numerator, this comes out to be x plus 3 upon 5. Now I need 2x plus 4 in the numerator, the derivative of the quadratic. So I multiply numerator and denominator by 2. So it comes out to be 2x plus 6 upon 5. Now I need plus 4. So adding and subtracting 4. 4 minus 4. So this is minus 20 plus 6 is minus 14 upon 5. So break into two integral containing in the one integral the derivative of the quadratic, that is 2x upon 4 upon this, and in the next integral simplify this part, which is minus 20 plus 6 minus 14 upon 5 into 5 upon 2 and upon this. Now when we let x square plus 4x plus 10 is equal to t, this 2x plus 4 will be cancelled out, and it comes out with dt upon root t. You know how to let it. If you don't able to do it directly, you take your own steps to do it. Now here simplify this, the numerator, 5 cancel out, it is minus 7 in the denominator, in the square root make it a perfect square. You know how to make a perfect square, adding and subtracting the square of the half of the coefficient of 4. I'm telling this many times in the last 5 to 6 questions. So half of the coefficient of x is 2, so adding and subtracting the square of 2, so this comes out to be x plus 2 whole square, and this is minus 2 plus 5, it comes out to be 10 minus 4, it is 6, that is root 6 whole square. So you can integrate 1 upon root 2. You know how to integrate 1 upon root t. You take your own space and a rough column to integrate this. 1 upon root t is the integration is 2 root t, and it is a special integral of 1 upon under root x square plus a square, which is log x plus under root x square plus a square. In place of x we have x plus 2, in place of a we have root 6. Replace the value of t. You can let it here that I have let it t is equal to x square plus 4x plus 10. Here we have let it here. So this is the integration by making the perfect square. Similarly is the question number 25. Here we have only to make the perfect square in the denominator. Now see it very carefully, because the coefficient of x square is not 1. So I am trying to make the coefficient of x square as 1. How can I make it? You can first of all take 4 common in this. So it comes out to be 9x upon 4 minus x square. And if you take out this 1 upon 4 out from the square root, it will be 1 upon 2. 1 upon 2 square root of 4. Now to make it a perfect square, again make the coefficient of x square as 1, because it is minus 1. Take minus common in it. It comes out to be x square minus 9 upon 4 x. Now make it a perfect square as usual. The half of 9 upon 4 is 9 upon 8. So 9 upon 8 whole square plus and minus, and this is the whole square of x minus 9 upon 8, and this is 9 upon 8 whole square. Arrange this negative sign. This will become positive. This will become negative in the square root, and it is a special integral of 1 upon under root a square minus x square, which is sine inverse x upon a, where in place of x we have x minus 9 upon 8, and in place of a we have 9 upon 8. So this is the completion of the integration by taking integration of a special integral, and in that we have integrated the integral by making the perfect square or linear upon quadratic type questions. You should do it at least 2 times to have a good command over these types of questions. Now after this we have an important topic to integrate the function by making the partial fraction. Now what is the meaning of partial fraction? Partial fraction means when we have the factors in the integration in the denominator, so you have to break it into the plus or minus sign like this. We have there are 2, 3 to 4 types, rather there are 3 types of partial fraction. First is dx upon x plus a x plus b. Second is dx upon x plus a whole square x plus b, that is we have the whole square. And the third type is in the denominator we have a quadratic polynomial which cannot be factorized, that is x square plus a or x square plus a square x plus b, like this. So first type is dx upon x plus a x plus b. You have to break into 2 integrals so that between that individual integral we have positive or negative sign between them. You have to break this product into plus or minus like this. Now first type is dx upon x plus a x plus b. When we have this factors of linear polynomial, you have to let it a upon first factor plus b upon second factor, a upon x plus a plus b upon x plus b. In place of 2 factors, if we have 3 factors, so you can let it like this: a upon x plus a, b upon x plus b, c upon x plus c. This is small c, this is capital C. We can have, you can take it d like this, and you make it d here. So like this. Now second is when we have the whole square in a factor like this, x plus a whole square, so you have to let it a upon x plus a, b upon x plus a ka whole square. See it here, a upon x plus a without square, b upon x plus a whole square, and c upon x plus b. In the third type, when we have the quadratic polynomial in the denominator, so you have to let it ax plus b upon x square plus a and c upon x plus b. That is above in the numerator for the quadratic polynomial, you have to let it here a linear polynomial ax plus b, or you can let it here a upon x plus b plus bx plus c upon x square plus a. Now what you have to do in these types of question, you have to find the value of ABC like this, and replace it in here. It will be converted into plus or minus sign between the individual fractions, and you can integrate easily. So this is the integration by this is the partial fraction, that is you have to break the this product factors of the polynomial in the denominator such a way that it should be break into individual integral having the positive negative sign between them, and they can integrate them easily. So let us begin with an exercise 7.5, and I will tell you in detail how you have to make it a partial fraction and how you have to integrate. Now this is integration of x upon x plus 1 x plus 2. So this is the integration by partial, making the partial fraction of first type. We have the factors of linear polynomial in the denominator. That is the first type we have, this type. So what you have to let? You have to let it like this. Let x upon x plus 1, x plus 2 is equal to a upon first factor, b upon second factor. And you have to simplify this equation to find the value of a and b, to find the value of a and b. So how you have to do it? You add it by taking the LCM. The denominator will cancel out. That is x plus 1 will cancel out of x plus 1 and x plus 2. That comes out to be x is equal to a x plus 2 plus b x plus 1. And you have to use this equation to find the value of a and b. Now how can you find the value of a and b? Now if you put x is equal to minus 1, you can detect from here x plus 1, x plus 2. So when we have, if we put x equal, first of all put x equal to minus 1 and then put x equal to minus 2 in this equation, you will get the value of a and b. There are two methods. The first method I am telling you, put first of all x is equal to minus 1 or x equal to minus 2, then you put x is equal to minus 1. I am putting x is equal to minus 2 in this equation. By putting x is equal to minus 2, I am getting minus 2 is equal to a into 0 plus b into minus 1. So I am getting the b as equal to 2. When I put x equal to minus 1 in this equation, I am getting the value of a as minus 1. So this is the first method to find the value of a and b. Now the second method is to find the value of a and b by equating the coefficient. You separate in the right hand side the such that you get the coefficient of x and a constant term. Equate the coefficient of x in the right hand side, and in the left hand side where the coefficient of x as 1, equate them and find the value of a and b. This is the second method you can find, but that is a long method. So try to find like this. Putting x equal to minus 1 and then x equal to minus 2 in this equation, you'll get the value of a and b. Now put the value of a as minus 1 and b as 2 in this here, minus 1 upon x plus 1 and 2 upon x plus 2, and integrate. Now simply we have integration of minus 1 upon x plus 1 plus 2 upon x plus 2, and you have to integrate. So this is the integration of log x plus 1 mod. This is plus 2 log x plus 2, log of mod x plus 2 plus c. Now you can use the property of the log in these two terms, and you can use the properties of the log, or you can leave it here. So this is the method to integrate by making a partial fraction. We'll discuss in detail in the next lecture. Thank you.